Hello, my name is Joshua Lyons, and welcome to the presentation, NoSQL, what it is, and how it compares to traditional systems. Let's begin with a quick overview of what will be discussed. The topics that will be covered are the history of NoSQL, the types of NoSQL databases, reasons and motivations behind NoSQL, problems with traditional relational databases, solutions that NoSQL provides, some advantages and disadvantages, as well as a list of current NoSQL databases based on the model types. First, the obligatory introduction. As mentioned in the beginning, my name is Joshua Lyons. I am in my junior year at Arizona State University with my major in software engineering. I've been programming for roughly the past 12 years in various programming languages. I first started programming when I was a meteorologist in the military. I started programming because I was lazy and wanted a way to automate my daily tasks. I have mainly used MySQL as a relational database of choice, and I am a NoSQL newbie. So, if there are any mistakes in this presentation, please feel free to leave a comment with any corrections. And yes, the image is how I look on a daily basis. Now, let's take a look at a brief history of NoSQL. The term NoSQL was first introduced by Carlos Strozzi in 1998, while he was developing his NoSQL relational database. His database still used relational database principles, just without the SQL interface. In 2006, Google published a paper describing a distributed file system called Bigtable. It was modeled as a multi-dimensional map distributed on thousands of machines containing petabytes of data. The model used by Bigtable is a wide column store. In 2007, Amazon also published a research paper on their database system called Dynamo. It uses a key value pair store that allows for horizontal expansion on a massive scale. And in 2009, Johan Oscarsson organized an event to discuss non-relational databases. The term NoSQL was reintroduced by Eric Evans to name the surge of non-relational databases. The widely adopted name means not only SQL. A better name to describe these databases could have been NoREL or non-relational, as most databases under NoSQL are non-relational databases. Next, the types of NoSQL databases. The first type of NoSQL database is the key value store. It is the simplest model in the fact that it requires only two things, a key to reference and a value to store with that key. Because of the simple model, it has a very high performance. The negative, however, is that the values cannot be indexed. The next type is the document store. Document stores are designed for semi-structured data like JSON or XML. They are stored with a key document pair. The difference between the key value store and the document store is that the structured documents can be indexed and searched. Because document stores are schemaless, they can contain any type of structure, and the structure between documents does not have to be the same. Documents can also have nested structures or documents inside them. This allows for quick processing as no joins are needed. All the data for similar objects can be contained in one document. Due to this flexibility, document stores are perfect for web applications. The graph store NoSQL type is as the name suggests. Data is represented in a graph where each node in the graph is a record of some type. Between the nodes are arcs, which represent a relationship type. Graph stores are used to represent complex data models with a lot of many-to-many relationships. This type is fairly new and not widely used. The last common NoSQL type is the wide column store. This was inspired by Google's Bigtable paper. They resemble SQL tables due to the use of rows as keys and columns as data. This type is used by Facebook and Twitter to store user content. Now, let's discuss the reasons and motivations behind NoSQL databases. There are three main reasons or motivations for NoSQL as I see them. Databases are schemaless, scalability, and agility. Because NoSQL databases are schemaless, any type of data can be stored at any time. There is no need to know exactly what type of data is required. This allows developers to add data as they need to. One document can hold different types and amounts of data, while another can hold something completely different, all in the same collection. Also, because these databases are non-relational, there is no need for expensive joins to retrieve the data needed. All the data can be stored in one single document. Scalability is a big reason for NoSQL databases. Because there is no requirement on relations, different chunks of data can be stored on separate servers. This allows the hardware to scale out, add more servers, versus scale up or upgrade to more expensive hardware. The last reason is agility. Developers can start programming from the beginning. With each iteration of a product, the way data is stored can change. This allows for quick development without the need to have a predetermined schema. Next, let's talk about some of the problems with SQL databases that NoSQL databases address. The problems that SQL databases have are expensive relational processes, scalability, schemas, and agility. The relational issues that are seen in SQL databases are through the use of expensive joins. Because relational databases split the data of objects between many tables, to get the correct object back, one would have to join multiple tables together, then filter out the unwanted rows. This takes time and processing power to compute. Another problem with SQL databases is scalability. Because SQL and relational databases require the data to be split up between multiple tables, the full database must reside in the same location. As more and more data is saved, more memory is needed. The only way to add this is to upgrade the hardware, which can get expensive quick. The other two problems with SQL databases are schemas and agility. Because the schemas must be predetermined in relational databases, there is no such thing as quick development, as most of the requirements must be determined at the beginning of development. This would fall under the waterfall method of development, which is known to be slow and not so agile. Now that we discussed the problems, let's talk about the solutions that NoSQL provides. The solution that NoSQL provides for the relational issues is that it allows all the data for an object to be saved in one document. This removes the need to join multiple tables together, which speeds up the data retrieval. It also allows for simple modeling of objects, which makes for easier development. For scalability, NoSQL provides an easy way to split data between physical hardware, as there is no requirement for the data to be in the same location. This allows developers to scale the databases out versus up, eventually saving money. Finally, NoSQL solves the issues between schemas and agility. Because NoSQL databases are non-relational and schemaless, there is no need for a predetermined data storage method. Developers can add, remove, or change the way their data is stored between iterations, which leads to a more agile way of developing software. Now that the problems and solutions between SQL and NoSQL have been discussed, let's look at the advantages and disadvantages that NoSQL has. The advantages of NoSQL can be boiled down to 4 items. Scalability, which has been mentioned a few times already, is a big advantage. The way NoSQL databases are designed allows the data to be split between multiple servers, and in the cases of Amazon and Google, between thousands of servers without issues or downtime. Another advantage is the handling of big data. Transaction rates have grown throughout the years just as the volume of data being stored has grown. Relational databases have been growing to keep up, but managing these databases are impractical for some enterprises. Today, NoSQL databases outshine the amount of data that can be handled at a lower cost. The next advantage is economy. This is a combination of the previous advantages. Because the cost to scale out a NoSQL database is much cheaper than scaling up on relational databases, the choice between the two based on cost is easy. The final advantage to NoSQL databases are the flexible models. Developers can choose the type of NoSQL database based on their storage preference. However, with relational databases, there is only one choice, and that is the row and column model. There are also 4 disadvantages to NoSQL. The first disadvantage is maturity. Relational databases have been around for a while. NoSQL has not. Because of this, a lot of the NoSQL databases are still in pre-production and working through issues. The lack of maturity leads into the next disadvantage, which is support. Because SQL databases have been around for a while, there is a ton of support for all the major brands. NoSQL databases have their history linked to open source projects, which offer little support and is usually learned on the go. The next disadvantage is administration. NoSQL was designed for zero admin support. However, installing and setting up these systems is usually more in-depth than the more popular SQL systems. The last disadvantage is advanced expertise. There are millions of SQL experts out there, and the majority of business experts have some relational database experience. But because NoSQL is so new, advanced experts are hard to find. Now that you know about the advantages and disadvantages of NoSQL, let's take a look at the main databases based on the NoSQL types. For the key value type of NoSQL database, the main systems are Couchbase, Amazon's Dynamo, and Oracle's NoSQL database. For document-based systems, there is Apache's CouchDB, MongoDB, and again Couchbase and Dynamo. For the graph types, there is Neo4j and Apache Giraffe. Finally, for the wide column types, there is Cassandra, Accumulo, and HBase. The references used in this presentation are listed here. If there was anything I missed or got wrong during this presentation, please feel free to leave comments below or send me an email. Thank you for watching.